I'm powering this breadboard at 5 volts. We can see on this side about 4.95 volts. But when we come to this side of the breadboard, we see about 4.94, flickering 4.95. This is a very slight difference because this entire rail has resistance. So it means this end ends up being different from this end. Here's another example. At this end, we see about 4.95. But all the way down here, we see nothing. This is why breadboards can waste hours. Most breadboards have this trencher split in the middle. That means this rail and this rail are completely split from each other. While the split rail is relatively obvious, it becomes more apparent whenever you want to use an IC chip like this one. Now, to power this chip, that's simple. All we have to do is connect this rail to this side, but for our ground, if I connect over here to our ground pin, I do not have ground on this side, so I'll have to bridge these two together. Or, alternatively, I can take a really long, goofy wire to connect from this side to that side. But this makes it a lot more messy. And also, the longer my wire is, the longer my resistance is going to be, which can present other issues down the line. However, connecting this side and this side's rail together can also create more resistance as well, and that's something you have to be cautious of. Also worth noting that no breadboard is exactly the same. Different manufacturers have different tolerances, different processes end up with different values. For example, this reads about 4.92 on 5 volts, while this breadboard ends up with about 4.84, 4.83, 4.85. That is a small but noticeable difference depending on what your resistance values and voltage values you're looking for. When bridging from one side of your breadboard to the other, verify that your voltage actually crosses the trench. Also, I want to point out that bridging my two rails together has somehow increased my power output. I am now reading 5.05 volts, which is a bit higher, about 0.10 volts higher than I was reading previously. I don't really know why it decided to do that, but that's kind of funny. Checking both sides, yep, we're at 5.05 volts now. I don't know why I did that. That's a problem with my Uno's power supplying and not so much the breadboard on that one, but something to be cognizant of. Another problem to be cognizant of is the more connections you make, the more prone they are to wiggling. This will rapidly change your voltage because your connections are going from connected, not connected at a rapid rate. It can also be caused by things like breadboard spring failure, but you know, breadboards aren't solder joints, so they are imperfect connections. So if your circuit only works when you press it, it's probably your breadboard and not your circuit. Sometimes an entire row will be just broken. This could be an internal problem, manufacturing defects, where you at that point you just stop trusting that entire rail. For example, all the way down here on this breadboard has stopped working. And it's not related to the voltage not being able to come all the way down here. It just doesn't work anymore. These two pins, something happened here. That's just, I cannot use those two. I can use this side, not that side. So this is a 100 ohm resistor, and it's gonna get quite warm in this test, but you know, I'm gonna use it as a load. Now, this is going to end up being subtle even when it's connected. No rail's perfect. There's going to be a subtle voltage drop, 4.68, but down here with our load connected, we see 4.6. It's a very subtle voltage drop. I'm removing that because it is getting quite warm under load, just being 100 ohms. With a load like this resistor, the behavior of the voltage changes. Loaded equals a current actually being initiated, which will drop our amount of voltage supplied. With this acting as our load, we can see that we actually do drop with it being loaded from one side of the rail to the other. That's just because this is a long wire. Under load, you get a voltage drop that can cause resets, sensor drift, and random behavior. Best advice when prototyping with a breadboard is to understand that this is not going to be perfectly representative of a real soldered board. Be aware that your bridges are going to be split from each other, and you should try to inject power into multiple places to avoid this side and this side having completely different voltages. And then keep high current off breadboards. Things like this DC motor will spike your voltage, which may reset your entire board if you're using this. But you honestly should not be running a motor and a microcontroller off of the same power rail. You should use a split rail using 2 different power supplies for that, or else you're going to end up resetting your Arduino every time this decides to turn on or meet any sort of resistance. Before blaming your microcontroller's code, maybe try blaming your breadboard. It's probably lying to you. But it is a great tool once you understand that it is a liar. Thanks for watching, guys.